So here we have is another question where we have been asked to find the Thevenin equivalent circuit. So we'll do it from the Norton circuit. So first we'll determine the Norton circuit. Okay. So for that we have to short these two terminals and find the short circuited current. Okay. Four ohm and 5 ohm. So this is IN. Okay. So here let's say this current flowing is I1 and this current flowing is I2. So IN is simply I1 plus I2. So I1 is simply 4.5 volt by 4 ohm because there is no other resistor in this mesh. So I1 is 4.5 by 4 ohm, which is around 1.125 ampere. Similarly, I2 here is 3 volt by 5 ohm because there is no other resistor here. So 3 volt by 5 ohm, which is 0.6 ampere. So IN is I1 plus I2, which is 1.725 ampere. So we have got IN. Okay, IN is 1.725 ampere. Now we'll find Rn, the equivalent resistance deactivating all the independent sources. So for Rn we have to short circuit the independent voltage sources. So here 4.5 volt is short circuited and 5 ohm short circuiting this. Five ohm, 4 ohm. Rn is simply 4 parallel 5 ohm because they are in parallel connection. So Rn will be basically 20 by 9, 5 into 4 by 5 plus 4. Okay, 5 into 4 by 5 plus 4, 20 by 9 ohm, which is around 2.22 ohm. 2.22 ohm. So we have got IN, we have got Rn is equal to 2.22 ohm. So from this we can determine the Thevenin circuit. So we have IN as 1.725 ampere and we have Rn as 2.22 ohm. Okay. From this, applying source transformation, VTH will be IN into Rn, which is equal to IN into Rn 1.75 into 2.22, which is coming around 3.83 volt. 3.83 volt. So VTH is 3.83 volt. And we have the same resistance, equivalent resistance connected in series, 2.22 ohm. this is the Thevenin circuit. This is the Norton circuit. So simply by applying source transformation, we got the Thevenin circuit from the Norton circuit. Okay. So here we have is another question on Thevenin to Norton and Norton to Thevenin conversion. So here we have this circuit and we have to find the Thevenin equivalent circuit. So we'll do it from Norton equivalent circuit. So first we have to find the Norton equivalent circuit. So first, Norton current, short circuiting terminals A and B. So this we'll short circuit these two terminals. This is IN, this is 2 ohm, this is 3 ohm, this is 6 ohm, this is 6 volt. So here we will be applying the concept of nodal analysis. So let us call it node 1 V1, this is node 2. Okay, the voltages V1 and V2 respectively. We have assigned node voltages. Now here if you notice, you will find something interesting, that in between the nodes V1 and 2, okay, there is this voltage source, independent voltage source 6 volt. So node 1 and node 2 combined forms a super node. Okay, node 1 and 2, they combined together form a super node, similar to super mesh, that is two meshes having a current source in between behave as a super mesh, and we apply KVL throughout the super mesh. Similarly, two nodes having a voltage source in between form a super node, and we apply KCL all total to that node. So here the Kcl equation will be like this. See, let us assign the current directions. Let's say this is 2 ampere. Let's say this is going downwards. This is also going downwards. This is ground. So here the Kcl equation will be applied directly. So first the auxiliary equation, V1 plus 6 minus V2 is equal to 0. That is the auxiliary equation, or we can say V1 is equal to V2 minus 6. That is the equation number 1. Okay. So when we apply KCL here, we will have 2, it is going towards this node. So remember, node 1 and 2 are combined, it is 1. So only incoming current to the node is 2. So it is 2 is equal to, all remaining are outgoing currents, V1 minus ground by 6, then V2 by 3, okay, then V2 by 2. Okay, pay attention, I have applied the KCL throughout the node, super node. So I have already made a video related to super node, so please watch that video. Here I am not going to again go into detail of all that, so please watch that video related to super node which I have posted. There I have explained in detail what a super node is, how to apply KCL in super node. So it is this equation. So now we will apply this equation, V1 is equal to V2 minus 6. We will replace V1 with V2 minus 6. Why? Because we need IN. Okay, IN. Our objective is to find IN, and IN is equal to V2 by 2 ohm. So for that we have to represent the equation in terms of V2. So we get the value of V2. So we will replace V1 as V2 minus 6 from the auxiliary equation 1 plus V2 by 3 plus V2 by 2. Okay, that implies 2 is equal to V2 by 6 minus 6 by 6 1 plus V2 by 3 plus V2 by 2. That implies taking 1 on this side becomes 3 is equal to, taking the LCM, 6 V2 plus 2 V2. So, I have taken 1 on this side to get 3. Okay, this becomes this V2 plus 2 V2 plus 3 V2. So, 3 V2 plus 2 V2 plus V2 is 6 V2. So, 6 V2 by 6 is equal to 3. Get cancelled, V2 is equal to 3 volt. That implies V2 is equal to 3 volt. IN is equal to V2 by 2, which is V2 by 2, IN is equal to V2 by 2, 3 by 2, which is 1.5 ampere. So, we have got IN is equal to 1.5 ampere. Now, is RN. We have to determine RN now. So, for that what we have to do, we have to determine the equivalent resistance deactivating all the independent sources. Okay, we have to determine the equivalent resistance. So, voltage sources will be short circuited, current sources will be open circuited. So, here current sources getting open circuited, (6 ohm), voltage source getting short circuited, 3 ohm, and this is 2 ohm. So, here 6 ohm and 3 ohm are in parallel with each other, the resultant is in series with 2. So, here RN will be 6 parallel 3 plus 2, which is 6 into 3 by 6 plus 3, which is 18 by 9, which is 2. 2 plus 2, which is equal to 4 ohm. 2 plus 2 is 4 ohm. So, RN is equal to 4 ohm. So, we have got IN and RN. So, the Norton equivalent circuit is 1.5 ampere, (4 ohm), this. Thevenin will be simply VTH is equal to IN into RN, which is equal to 1.5 into 4, which is 6 volt. So, this is simply source transformation. Thevenin voltage is 6 volt and we will have the same voltage in series, 4 ohm. This is the Thevenin equivalent circuit, 6 volt in series with 4 ohm. So, this is the Norton circuit, this is the Thevenin circuit, simple application of source transformation. Okay. So, here we have discussed questions related to conversion between Norton and Thevenin and Norton. Okay. So, whichever one you are comfortable with, we can use and find the other.